Welcome back. In part 1, we defined the $1 trillion trap. Today, we enter the core of that trap, the invisible opponent that even Microsoft, Google, and Amazon can't defeat with software alone, the physical limits of the aging electrical grid. Project Stargate is the most ambitious compute build-out in human history, but when you try to plug 5 gigawatts of load into Virginia's data center alley, the physical world sounds an alarm. The scale is simply too large for 20th century wires. Northern Virginia handles 70% of the world's internet traffic, but its substations are effectively saturated. If you apply for a 100 megawatt connection today, you're not looking at months, you're looking at 5 to 7 years just to get a maybe. This is the interconnection queue. Across the US, over 2,600 energy projects are waiting to join the grid. By the time you get your electrons, your H100s might be 3 generations obsolete. The queue is the real AI bottleneck. This isn't just about red tape, it's about hardware scarcity. The lead time for a high-voltage transformer has surged from 50 weeks to over 150 weeks. Without these massive iron cores, your compute hub is just a dark building. Only a handful of factories worldwide can build these transformers. Raw material costs are spiking, and specialized labor is in short supply. Every grid expansion is a multi-year physical slog that capital cannot easily bypass. Here's the most controversial part of the audit. To upgrade the grid for these power-hungry AI farms, billions in costs are being shifted. In some regions, up to $4.3 billion in infrastructure expenses are being added to everyday household bills. Retail energy consumers are essentially subsidizing the AI supercycle. This is a massive capital transfer from the public to private infrastructure, and it's triggering a political backlash that most investors have completely ignored in their ROI models. It's not just about capacity, it's about stability. When massive compute clusters fire up, they create voltage and frequency spikes that can damage sensitive hardware. The grid is becoming dirty, and that is a lethal risk for GPUs. Dirty power means data centers must invest hundreds of millions in dedicated filtering and stabilizing equipment. This hidden stability tax further erodes the profit margins of pure-play compute providers. The grid is an unreliable partner. Big Tech's solution? Thousands of backup diesel generators. It's an expensive, inefficient compromise that directly contradicts their net zero promises. They are choosing physical survival over sustainability because the grid is failing them. This is where the AI dream hits the environmental wall. You cannot have 5 gigawatts of 24/7 power from wind and solar alone. The physical world is forcing a return to firm, reliable power sources, regardless of the carbon cost. We are seeing a voltage war. Standard 230 kilovolt lines aren't enough. Tech giants are pushing for 500 kilovolt ultra-high voltage projects, but these require more land, more permits, and more demolition. The friction is endless. The regulatory wall is already rising. Ireland and Singapore have both implemented data center moratoriums to protect their local grids. The era of build anywhere is over. Power availability is now the primary constraint on AI sovereignty. In my research, we've found that energy OPEX is now the fastest growing line item for LLM training. If you aren't optimizing your PUE to below 1.05, you aren't building a model, you're just buying electricity at a premium. The verdict of part 2 is clear. The grid is no longer a public utility. It's a scarce, finite asset. If you don't have a plan to bypass it, you're not an AI player. You're just another victim of the trillion-dollar trap. So, how do big tech giants break the chains of the grid? What is the one energy source dense enough to sustain AGI? In part 3, we reveal the nuclear alpha. I'm Wang Yu. I'll see you in the next briefing. Briefing concluded. System saving grid stress data, secure terminal,